So we have the two questions. The first of all, you're gonna see that one independent voltage sources, one independent current sources, and then one dependent current source, 3ix. But the I sub x is the current passing through the resistor R, the 8 ohm. Okay. All right. So if we find A, we can find the B is very it's easier. For example, you find the Thevenin voltage and register right there. You can the transformation, okay, like this one, the R sub n. I'm sorry, this is the n. This is same as R sub th. That was what? Th divided the R sub th. This is I sub n. All right, so that was the source transformation. So So if we find the Thevenin equivalence circuit, it's really easy. So, all right, step by step. So if we wanted to approach to solve this question from here, first of all, we have to find the open circuit voltage V sub OC. In here, that was V sub OC, same as V sub AB. And then the next step, you have to find the Thevenin voltage. Yes, definitely. But maybe again, there is a lot of approach, but we try to in the class we find V sub OC using by nodal the analysis, and then the step three deactivated all independent sources and apply to test voltage sources the V sub T, the terminal pair, the A sub B. Again in here the we can deactivate the independent sources. However, the dependent sources that could not deactivate. Okay. It was very important. Okay. All right. So after that, we're going to apply test voltage V sub T at terminal pair A and B and use the KCL to find resulting sources, the current I sub T. And finally, we can find R sub TH. That was V sub T and I sub T, maybe right there. All right. So again, that is the same question. Okay. Same question from the books. Okay. So here we go. All right. So step one, we have to find essential node. Okay. Essential node. How many essential node? That was, this is essential node, but that was the ground here. Okay. Right there. So that was, we're gonna just ground. And then the second essential node, like this one. Okay. This is, for example, B. And the last one, essential node, like this one, we're gonna call it, that was the V sub A. This is V sub B. Okay. So I'm gonna just, oops. Okay. So that was for, we're gonna just the B node and also V sub B. This is the 8 node, that was V sub A. So the measurement, the essential node, that was the same voltage difference. Okay. So step one, we have to find open circuit voltage V sub OC using the nodal the analysis. Okay, so I'm gonna change the color. I'm gonna just change color, maybe green here. Okay, now, so in here we learned before V sub OC is the equal to V sub AB, right? So nodal analysis. Oh, by the way, V sub A is what? The 24 voltage. Okay, so here we go. So nodal analysis from node B, we can V sub B minus V sub A divided 2 plus leaving current, okay? The current dependent sources, 3I sub X, 4M, and also um, the I sub X. And also we can be writing V sub A is what? The 24 voltage minus 24 divided 2, 3 times I sub X plus 4 plus, oh, I'm sorry. This is the 4ix. I'm writing here. 4 plus 4ix is going to 0. Okay, now, Now, so what is the I sub x? It's right there. So the I sub x is V sub b, so divided the 8 ohm. Okay. And also, V sub A is Thevenin voltage. So now that was for, we're gonna just, V sub B is 8 times the I sub x, right? Just plug in the previous, the equations. We have to 8 times I sub x minus 24 divided 4 plus 4 I sub x. And 4 times I sub x minus 24, 8 plus 8 I sub x is the equal to 0. 16, I sub x is what? 1. So right there, I sub x is equal to 1 means V sub B, the 8 voltage. Okay? So means V sub B is what? I'm going to have a different color. Okay, right there. So V sub B is V sub AB, the open circuit. That was the Thevenin voltage. So now we found Thevenin voltage, the 8 voltage. Okay. So go back to the step 4. We're going to finding. Um, so after we find the open circuit, this is step 2, right? Step 2. And then we're going to just for which is to deactivate it or independent sources means independent sources. We can draw. I'm gonna redrawing for you. Redrawing for you, like this one. Right here we go. This one. This one. So the voltage sources should be short circuit, and independent current sources that was the open circuit, right? And then we have to adding for test voltage. Okay, right there. All right. So more in detail from the book, from my the lecture. Again, same question from my lecture printout from the book. Same question. You can check in the book as well. Okay. This is the 3I sub x. Oops, this is the 2 ohm. Okay. All right. This is the 8 ohm. All right. That was for what? This is deactivate the independent sources. So again, with dependent one, they cannot more deactivate it. So in here, we adding to the test voltage. Okay. Okay. The test voltage. So we can redraw the circuit like this one. Okay. 2 ohm, the 8 ohm, plus minus, V sub T, times I sub X, the I sub T. Okay. All right. So now, so the I sub T from this circuit, we can, the I sub T is what? Right there. So V sub T over 8, V sub T over 2, 3 times I sub X. Okay. What is for I sub X? We learned before in the previous circuit, the I sub X is what? The current in here. The, the passing through the I sub X. So that was the I sub X. So it means that was I sub X plus V sub T over 2, 3 over I sub X. Okay, this is the I sub T. So it means, so the I sub X, oh, I'm sorry, this is the rewriting V sub T over 8 plus V sub T over 2. That was V sub T over 8 at the times 3. Okay. So that is what? That is 481 plus 84 plus 83 V sub t. This is the I sub t here. That was what? It's 1. So the I sub t is equal to the V sub t. Go back to the approach. Use KCL to find resulting sources current I sub t and define Thevenin the register in here. So t over V sub t is like a Thevenin register. That was for 1. Why? Because right this one. Again, that was include the dependent sources here. So this is why we're going to apply for the test voltage sources in the circuit. And then we can find the Thevenin register in the another way. Okay. All right. So that is for what we wanted to do. So finally, we can draw the Thevenin register. This is Thevenin register. This is the open circuit, A sub B. What is the A sub B in here? It's right there. Okay. So this is a Thevenin register that was 1 ohm. And then the Thevenin voltage, that was for what? We have already calculated before, the A voltage. We can source transformations, direction like this one. This is 1 ohm. This is 8 amp. Okay. So that is the answer. All right. And then the second one, that was my maximum power transfer question. This is the maximum power, the transfer, the question. Okay. So for the circuit in the figure, we have to find the R sub L, which is the maximum power being transferred to the R sub L. Okay. So do you remember in the books, in the homework, in the lab session, we have similar, same circuit, a lot of time practice. And also I have already the record video before. So if they wanted to the maximum power in the R sub L, the Thevenin register and the road register should be the same. So it means we have to find the Thevenin register. How? So the direct method, that wanted to short circuit. Okay, short circuit. Like this one. Okay. This is node. Okay. So this is node. So that was 180 ohm. And that was for 30 ohm A and B. This is the 20 ohm. So that was for 50 ohm. Okay. That was 180 ohm. This is the pedal. So 50, 150, 50 plus 150, 50 multiply 150, 200. So 220, 37.5 ohm. So Thevenin register, that was 37.5 ohm. Okay. All right. So, but we have to find, how can I say? Okay, so that is the answer for the A. Maximum power, the power at the road register, that should be the same. Okay, 37.5, the ohm here. Okay, all right. Let's say the B. Okay, is B. Calculated the maximum power of R sub L. So we the long before the maximum power. This is the formula, right? In the lab session, a lot of question, homework from the class. We practice a lot of things. So 4 times R sub L, V sub TH square. Okay. So 4 times 37.5 V sub TH square. So now if we don't want to piece of max, we have to find the Thevenin voltage. Okay, how can we find this one? All right, what is the Thevenin voltage in the circuit? So open circuit, That was V sub AB. That was the terminal voltage. Okay. All right. So how can we find this one? This is just series circuit. So means that the Thevenin voltage is what? The total current multiply 150 ohm. So how can we find the I sub t? I sub t, well, this is the just the circuit. So 300 voltage divided 50 plus 150 was 200 ohm, 300 voltage, 1.5 amp. So now this is 1.5 amp. Just multiply 15, multiply 15, 200, just 15 and 15, 225, 225 voltage. Okay, 225 voltage. So go back to here. Let's say 225 voltage divided 4 times 37.5 ohm. So I'm gonna, after calculating, I'm going to just calculating, let's say 225 square divided 4 times 37.5. Okay, we're gonna just calculation by calculating 337.5 watts. All right. So the last one, when R sub L is adjusted for maximum power transfer, what percentage of the power delivered to 300 volts? So this is the wrong typing. We have to change 300 voltage sources reaches the R sub L. So now we have to, let's say, hey, C circuit, one more time. There was not recording video. System issue. Sorry about that. So we can, simplify the Thevenin register V sub TH and the R sub TH. And after just connect to the load register right there, we can find V sub AB, just the help, right? So 100, the 12.5 is the V sub AB. So from the original circuit, okay, that was for maybe after connect to the R sub L with the Thevenin register, Thevenin voltage, that was for what? V sub AB, that was for 120.5 voltage. So that was also V sub AB. So 300 minus 112.5 divided 50 ohm. That was for 3.75. This is the source current. So the power at the supply voltage, I sub S multiply 300 volt. This is the 1,125 watt, but the minus bell is like supply, okay? So the maximum power at the load register, divided the source voltage after connect to the load register, multiply 100. That was the 30%, okay? And then the one more questions is for source transformation, the bonus questions, that was the original circuit. We can, source transformation from the Thevenin register to the Norton registers, kind of the 25 divided 5, so like 5 amp, the going up direction current sources, and the register just connected or in parallel, still the same register. So 5 and 20 that are in parallel. So we can calculate it 4 ohm. And also the two independent, the current sources are in parallel. Definitely they can adding up the 8 amp. So the 8 amp are in pair with 4 ohm. That was the 32, the voltage. Okay. This is the this is the one more time, the 8 amp, 4 ohm. Oops. And this is the 4 ohm. Okay, that was 32 voltage. 4 ohm and 4 ohm. This is A and B. This is A and B. So this is the what? The 4 ohm. So that was also 32 divided 8, the 8 ohm, 4. So 4 ohm, 4 ohm independent sources with are in parallel connection, 8 ohm. That was looks, that was